Okay, we have finally finished going over all of the laws of exponents that we're going to cover in this class. If you go on and you study algebra a little bit more, you can then extend exponents and try to figure out what it means to have a fractional exponent or just in general a real number exponent. And you can extend that as much as you can even get into complex numbers if you start going that route. In any case, this is as far as we're going to get. We're dealing with positive and negative and zeros, just integers. So let's recap what all the different rules are and try to give you guys some sort of method of organizing them, because there's a bunch of different rules and it's hard to keep them all straight. So first off, if we have the same base and we're multiplying these two things together, what we end up seeing is we end up adding the exponents. If we have the same base but we're doing division, we end up subtracting the exponents. So those two fit very nicely together. You can either add or subtract the exponents based on if you're increasing the number of factors or if you're decreasing the number of factors. Alright, next up we have the two that look like the distributive property, or that are distributive properties really. So a product raised to a power, this would be a to the r, b to the r. This one right here, we have a quotient raised to a power. This is a to the r over b to the r. These two, we've actually been using them quite a bit. This is, it's just a distributive property. All right, next up. All right, the next law of exponents that we see doesn't really have a counterpart. Like the previous two, you can see they fit together pretty nicely with multiplication or division, multiplication or division. This one doesn't really have a counterpart because there is no multiplication or division in it. It's just repeatedly raising something to exponents. You multiply the exponents. And this one, a zero exponent doesn't really have a counterpart either, so I kind of put those together just because they're the only ones that don't really have counterparts. Raising something to the power of 0 is just equal to 1. And the last three, these are kind of the same sort of idea, so that's why these fit together very nicely. If you have a negative exponent, essentially it just means that this base is in the wrong place. If you have a negative exponent that's in the numerator, it means you should move it down into the denominator to give it a positive exponent. If there's a negative exponent in the denominator, it means you should move it up to the top to become a positive exponent. And if the entire fraction has a negative exponent, it means you need to move both of them. Whatever's in the numerator needs to move to the denominator and vice versa. So you end up taking the entire reciprocal there. So these are all the laws of exponents that you need to know. Let's see if I can fit them all on the same page. These are the laws of exponents you need to know, and we'll do a few more examples before we move on.